Whenever I'm factoring, I always try to I always check for the greatest common factor first. So this one does not, number one does not have a greatest common factor. I have an x in two of them, but not in all of them. I have a number that's divisible by 2 in these two, but not by all of them. So this is 3 terms. So what I'm going to do is I'm going to find factors of negative 168 that add up to negative 2. So that means there's two numbers that I multiply that are 2 units apart. So like 10 and 12, 5 and 3, 7 and 9. So I need to find factors that are 2 units, 2 numbers apart that add up to, that multiply to negative 168. So those numbers are 12 and 14 because 12 times 14 is 168. Now it's going to be negative 14 and positive 12. And number 2, I try to check greatest common factor. No, it doesn't have a greatest common factor. So then this number has the coefficient of x squared is not 1. So I'm going to do 4 times 9 and I get 36. So two numbers that multiply to 36 and add to 12 are going to be 6 and 6. So instead of writing 12x in the middle, I'm going to write 6x and 6x. So the polynomial is still the same, I just stretched it out. I do that because now I can factor by grouping. I'm going to factor out a 2x and get 2x plus 3. And I'm going to write 2x plus 3 over here and work backwards. So in order to get 6x plus 9, from 2x plus 3, I have to multiply this binomial by 3. So I'm going to write plus 3 right here. So in the end, you have 2x plus 3 times, because it's the outside, times 2x plus 3. So you can write it like this, or you can write 2x plus 3 squared. Number 3, I don't have a greatest common factor, so I'm going to do factors of negative 8 that add to negative 7, because there's this number in front of you here is not, or it's 1, so I can just do x minus 8, x plus 7. Number 4 is difference of squares. So one is going to be positive, one's going to be negative. One's going to be x, because x times x is x squared, and then 9 times 9 is 81. And then number 5, no greatest common factor again. The number in front of here is 1, so I have to think of factors of 16 that add to 17. So that's 16 and 1. Number 6, same thing. There's not a greatest common factor. The number in front of here is 1, so I do factors of negative 6 that add to negative 1. So that's negative 3 and positive 2. Number 7, first I'm going to do the greatest common factor. Don't stop after you get the greatest common factor. See if you can factor further. So this one I can still factor out into x plus 7 and x minus 7. This is difference of squares. So I'm going to have a plus and a minus. To get x squared is x and x. To get 49 is 7 and 7. Number 8, no greatest common factor. So I'm going to do 12 times negative 5 is negative 60. So factors of negative 60, they add up to 4. So they have to be 4 units apart. So it's 10 and 6. So I'm going to write 12x squared. Instead of writing 4x, it's a positive 10x and a negative 6x. So now the polynomial is not changed, it's just spread out. You took the 4x and you wrote it like this. So now I'm going to group this And this is going to be 2x times 6x plus 5. Copy 6x plus 5 over here. And I need to work backwards and think about what can I multiply 6x plus 5 by to get negative 6x minus 5. It's negative 1. So then I can put these two together and do 2x minus 1. And my remaining binomial is 6x plus 5. Okay, number 9. No greatest common factor, but I have difference of squares. So this is going to be 5x plus 3, 5x minus 3. Number 10, no greatest common factor. So I do factors of 26 that add up to 13. So factors of 26 are 1 and 26, 2 and 13. And that's it. None of these pairs will give me 13. So this one's not factorable. Number 11, there's no greatest common factor. So I do factors of negative 11 that add up to positive 10. So it's x plus 11, x minus 10. Number 12, no greatest common factor. So the number in front of here is 2, it's not 1, so I'm going to do 2 times negative 7, which is negative 14, and find factors of 2 times negative 7 that add up to negative 5. So that's going to be positive 7, not positive 7, oops, it should be add up to negative 5. So negative 7x plus 2x minus 7. I just expanded this. Now I'm going to factor by grouping. So this, I can factor out an x and get 2x minus 7. Then I'm going to copy it over here, 2x minus 7. So this had to be a 1 because it didn't change. It's the same thing. So I'm going to put the outsides together and copy down 2x minus 7. And then number 13, no greatest common factor. So I'm going to do 4 times negative 15 is negative 60. And I need to add up to get negative 4. So that is going to be negative 10x plus 6x minus 15. So I just stretched out negative 4 to be negative 10 plus 6x. Now I'm going to take the greatest common factor of these two, which is 2x, copy over here 2x minus 5, and fill in what do I multiply 2x minus 5 by to get 6x minus 15. I multiply it by positive 3. So at the end you put 2x plus 3 together with 2x minus 5 for your two binomials. Okay, number 14, same thing. There's not a greatest common factor. So I'm going to do multiples of 8, because 2 times 4 is 8, that add to negative 9. So that's going to be negative 8x and negative x. Factor out greatest common factor of 2x, and then copy down the x minus 4 right here. So this number had to be negative 1. So I'm going to put the outside together. And then number 15 is difference of squares. There's two terms that we're subtracting. We can take the square root of both of these. So I'm going to have a plus and a minus. And then a 2x, and a 1, and a 1. And then 16, This one looks like it's a perfect square trinomial because I recognize that I have 9x squared and 16. So I'm going to try this and see if it works. So 9x squared is 3x, this is 3x, this is going to be a 4 and a 4, and I'm going to add them and see if I get 30. So does it work? So if I have 12x and 12x, no, it doesn't equal that. So I'm going to have to do it longhand, the long way. I was hoping it would be a perfect square trinomial, but it's not. So I'm going to do 9 times 16. So factors of 9 times 16 are 144. 144 that add up to 30 are 24x and 6x. So these two I can factor out a 3x. And I can write 3x plus 8. And then this has to be a 2, so it's 3x plus 2 times 3x plus 8. I'm going to forward through until the back side of these, so you can finish out these. So this is a very specific type of way to solve or to factor out. If I'm noticing that it doesn't have a greatest common factor, and this has degree 4 and this has degree 2, and it looks similar to a quadratic trinomial. It's got 3 terms, but I have a 4 and a 2 instead. So what you can do is think of letting a different variable be x squared. So now, if you let u be x squared, instead of writing x to the 4th, that's actually u squared. Because x squared times x squared is x to the 4th. So now I have u squared plus 5u minus 6. I'm factoring this out. So all I did was just change my variables. So watch, this factors into u plus 6, u minus 1. And at the very end, I know that u is x squared, so I have x squared plus 6, x squared minus 1. Now I can take this polynomial even further because this x squared minus 1 factors out into x plus 1, x minus 1. So using that same technique, this would be u squared plus 6u minus 40. This factors into u plus 10, u minus 4. So in the end, you have x squared plus 10, x squared minus 4. But we know that we can take this further. X squared plus 10 no longer factors, but x squared minus 4 is difference of squares. So go ahead and try the next two. This one you're going to let u be x cubed.